Okay, good morning, afternoon, or evening, participants. We've got quite an international crowd today. Welcome to the Connect to NASA Renewable Data Resources with GIS Earthdata webinar, and this is your host, Jennifer Brennan. So while everybody's logging in here, many of you have already noticed we do have two optional polls at the bottom of the page, and you can find those in the left and middle portion of your screen. We do appreciate your feedback on those. So we have got 2 p.m. Eastern Daylight Savings Time, and we are going to go ahead here, and get started. First, what I'd like to do is begin with a few housekeeping items related to this webinar. Okay, to ensure best audio experience, the conference has been placed in silent mode. So if you have any issues or you have any questions, what I'd like for you to do is to enter those into the Q&A pod located on the lower right-hand side of your screen. And again, this works like a chat. The webinar is being recorded and will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. And I will provide the URL to everybody at the end. Additionally, all presentation files will also be available for download at the end of the webinar. As far as timing is concerned, this webinar is 1 hour long. We've allocated 45 minutes to the presentation and demonstration with an additional 15 minutes for the question and answer period. So after our speaker has finished his presentation, what we'll do then is we'll move to a final set of polling questions, and then from there we'll transition directly to the Q&A period. So remember, you will have an opportunity to ask your questions throughout by using the Q&A pod, but due to the large number of participants, questions will not be answered using the raising hand function. It has been disabled. One final note, depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. Eastern Time for those of you who may wish to stay on the line. Alrighty, and what I'd like to do next is move to our agenda. Let me pull that up for everybody here. During the first 15 minutes or so, our speaker will provide an introduction and also an overview for the NASA Surface Meteorology and Solar Energy Project and Applied Geospatial Technologies. Following the introduction, our speaker will go through several use case scenarios that will include a use case specific discussion of how to discover and access and also use these SSE data products. From there, we will transition to a demonstration of the SSC Web Mapping application, and finally, we'll wrap up with information about some developer tools. With that, it is my pleasure to introduce our speaker today, Jason Barnett, who is a geospatial specialist at the NASA Atmospheric Science Data Center, or ASDC, Distributed Active Archive Center, or DAAC. Jason?
Thank you, Jennifer. Well, good afternoon, everyone. My name is Jason Barnett, and I am an associate with Booz Allen Hamilton and a geospatial specialist supporting the Atmospheric Science Data Center, ASDC, and the prediction of worldwide renewable energy resource power project in support of Dr. Paul Stackhouse. This afternoon, I'd like to walk you through several new initiatives to connect high-quality NASA science research data sets to the renewable energy sector and to its diversifying user community using geospatial technologies. So during this session, I'll be providing you a brief project background on the NASA Surface Meteorology and Solar Energy, or SSE web portal, the geospatial technologies we are working to implement to make the data more accessible to a diversifying user community, and to navigate through a few sample use cases that I'm hoping may better help you understand how our new technologies can be utilized from anyone from, say, a 4th grade teacher all the way to a computer developer. So let's step back and look at the roadmap of where SSE has come and where we're going. In the mid-1990s, an effort began that eventually involved collaboration with DOE National Renewable Energy Laboratory, or NREL, and the Natural Resources Canada RET Screen International, and numerous other partners in industry and universities to make progressively improved NASA science data products available for renewable energy and other energy-related applications over the Internet. And in 2002, the NASA Applied Science projects were initiated, providing a more focused effort to accomplish the goal of empowering energy-related decision support tools using NASA meteorological and climate-related data sets. So this resulted in a systematically improved web portal called the Surface Meteorology and Solar Energy that aimed to make long-term solar energy and meteorological data sets available to energy sector-related industries. That includes sustainable buildings and agroclimatology. And these improvements were based upon improved solar and surface meteorological data products from NASA science research and the introduction of new parameters based upon those data and interactions with users. So the web usage of these tools in terms of numbers of users and data delivered has grown nearly exponentially at times. And the success of the website was found in the provision of data sets via an ASCII format on a very site-specific basis for use in decision support tools. But as a result of the success of the SSC project, NASA's Applied Science program supported the development of the Prediction of Worldwide Energy Resource, or POWER, project and data portal, which you can see on the far left side of that roadmap. The Power Data Portal, initiated in 2003, currently encompasses SSE and includes two additional components, one with a focus on solar and meteorological parameters of interest to the sustainable buildings community, and the other is focused on solar and meteorological parameters of interest to the agricultural communities. Now, SSE is the most mature of the three Power Web interfaces and currently has the largest user base. Moreover, through the SSE Data Portal, solar and meteorological parameters of interest to the agricultural communities are also available and have been found useful for both temperature and solar energy quantities. So the data that's provided through the surface meteorology and solar energy currently includes a 22-year climatological monthly and annual averages and a daily time series with a limited set of parameters. Now, these are solar energy and surface meteorological parameters from NASA satellite and reanalysis projects, and they're being used for renewable energy applications. So the date range currently goes from July 1st, 1983 all the way to June 2005, and is a global 1 degree by 1 degree spatial grid resolution. Now, the solar radiation parameters, such as insolation incident on a horizontal surface, those are derived from NASA's Global Energy and Water Cycle Exchanges, the surface radiation budget. And the near-surface meteorology data, such as temperature at 2 meters, those are from the Global Modeling and Assimilation Office, the Goddard Earth Observation System Assimilation Model. Now, there are newly revised data products from GMAO and the SRB, and now also the Clouds and Earth Radiant Energy Systems, or series, that are being prepared and assessed to replace these data products in the future. So currently, the SSE data products, the data set itself, provides a plethora of parameters, both solar and meteorology, as you can see here, and each of the parameters are categorized into parameter classes based on what users tend to be looking for. So for example, there are parameters for solar cooking, sizing and pointing of solar panels, solar geometry, tilted solar panels, and different meteorology parameters such as temperatures and wind, etc. What I want to do now is give you a brief demonstration of how a current user accesses the data through the SSE portal currently, the way it's set up. So when they come to the SSE website, they have several different data access capabilities. You have things like data tables for a particular location. You can look at regional data subsets. You can retrieve some daily data, download the entire globe data set parameters, as well as look at some interannual variability. So if a user were to do the global data set download, they'd have a list of all the different 22-year averaged and 10-year average climate and solar radiation parameters that they could click on and download in a form that is an ASCII form that looks like this. The users, or traditional users, have taken this data and then copy and pasted it into an Excel spreadsheet or into their own databases or whatever they're using the data for, and it's being formatted with the latitude and the longitude and then each of the 22-year averages for each month, January through December, and then the annual averages. Another example is if a user wanted to get data for a particular location on the Earth, not the entire globe, they could use the data tables for a particular location. And what this does is this requires the user actually input a latitude and a longitude. And they have to know their latitude and longitude here. So once they put in the latitude and longitude and they submit it, they are provided with a long list of parameters that they can choose from. They can choose one or several of these different parameters, which are grouped in those parameter classes. And upon hitting submit from this page, they are actually then brought to a page with an HTML tables of those values, the parameters that they chose, where they can now copy and paste it or use the values however they need for the application. So traditionally, the surface meteorology and solar energy, renewable energy data sets have been widely utilized by a growing list of government, private, and higher education communities. However, with increased availability and use of technology and internet connections in the classrooms, in boardrooms, increased mobile data coverage and download speeds, the demand for data to be brought to the end user where they are is the new norm. So the daily use of NASA data is expanding each day beyond the scientist or the data modeler. It's going to the teacher in a fourth grade classroom, the homeowner looking to install a solar panel, a coffee shop owner hoping to reduce their energy costs, and perhaps even a small, sustainable, woman-owned farm looking for information on past climate patterns to better forecast her business economically and ecologically. And so where exactly are these users, these SSE data users, coming from? Well, this map simply shows a sampling of user visits to the Surface Meteorology and Solar Energy website for July and March 2015. You can see from this map that the users are dispersed throughout the globe, and not just business owners, teachers, scientists, farmers, modelers, or renewable energy specialists in the United States, but users across several countries. Now, however, in the U.S., where the largest user base is concentrated, there were close to 16,000 web hits in March and approximately 26 web hits in July 2015. Now, the United States is by far the largest user base of the SSE data set, but since the data is based globally, other countries have been able to leverage it as well, to include places like Russia, or looking at countries like Spain or Germany, or Ethiopia, and Argentina. And the list goes on up to 177 different countries and national affiliated territories. However, with a diversifying user community beyond the scientist and the data modeler, these new challenges are surfacing. The new users are forced to navigate through what data is available, how do they use it, how do they visualize it, how do they incorporate it and actually provide value-added benefit to their fourth grade students, to their bottom line, to their forecasting costs, or what have you. Many of them not knowing where the data is coming from, the modeling and validation behind the data, what satellite was used, how good the data is in terms for what they need, or is it even in the right units for what they're trying to use, how to use it even as an input for another data set that they need. Excuse me. And for those that are using the renewable energy data sets on a regular basis, that are using these SSE data sets on a regular basis, what have we been hearing from them? Well, the traditional users have requested data outputs beyond the ASCII and the HTML tables. They're looking for enhanced visualization. They're looking for tablet and smartphone enablement, and to have the data more discoverable and usable. So this process has brought us to these past 2 years. And how are we addressing these issues? What are we putting in place to kind of better meet the needs of this diversifying user community? Well, the answer is a robust geographic information system, or GIS. And these geospatial technologies are opening avenues for users to discover, visualize, and analyze data that is relevant to them on their desktop internet browser, smart boards in the classroom, a smartphone on the couch, or tablets out in the field, allowing project managers to add additional information to their decision workflows, opening a suite of tools for application developers, or empowering the computer science, the oceanography, the geography, or the business college student to research and develop new ways to evaluate their data and ours at their fingertips, and to discover patterns and make better informed decisions. So the Atmospheric Science Data Center, in partnership with the Surface Meteorology and Solar Energy Project, have launched themselves down a road to meet these needs and the users in their place, to provide a community and platform to more easily access their data, and put these tools in place to allow the user to easily massage the data into a story, into a lesson plan, a business meeting presentation, or even a final term paper. And these efforts are impacting the user where they are in a means that is hopefully more convenient and even more easily understood. And so the Surface Meteorology and Solar Energy GIS project was launched as a pilot 2 years ago to explore the options and technological capabilities that exist to connect NASA's data to its diversifying user community, and work to meet the user where they are and in the confines of their technology. And our objectives for the initial pilot program were to first process and reformulate current data products available through Power and SSE websites, to formats and data parameters consistent with Esri and OpenGIS tools that could be useful for decision support systems that rely on GIS. And secondly, we wanted to develop functions to improve functionality and analysis that mimic the capabilities of the current site to produce on-the-fly data products on a location-specific basis and extend these past a single location to a regional and global scale. And thirdly, to update the current website to enable both web-based and mobile application displays of these parameters, make it responsive to the platform. And lastly, we really wanted to interact with the user communities and government and industry to test formats and usage for optimization and develop a series of metrics to allow for monitoring of performance. And so the SSC GIS effort ensured that we were working in collaboration with the U.S. Department of Interior, the National Renewable Energy Laboratory, NREL, Red Screen International, the U.S. Department of Agricultural's Arid Land Research Center, Homeowner Energy in the private sector, and of course, the Atmospheric Science Data Center. And at the inception of the pilot, it was important to engage with those stakeholders that were constantly using the data, or advocates for geospatial data discovery and use nationally and worldwide, such as groups like Red Screen International, that now have over 460,000 users worldwide in 36 different languages. So what else does this collaboration look like? Well, since that time, ASDC and SSE have further expanded their community to additional interested science teams and various capacity building efforts. And SSE is collaborating with ASDC to add GIS capabilities for new and improved access to the renewable data products. And so the Atmospheric Science Data Center is launching a suite of SSE geospatial data and tools, which include Esri ArcGIS Image Services, available also as REST and JSON, and an SSE Web Mapping application built within a responsive platform, so it's available on desktop, tablets, and mobile phones. So as we work to launch these new geospatial capabilities, I now wanted to provide you with a sampling of use cases in which we are working to meet the diversifying user community where they are. I have 4 sample use cases that I hope you will help better clarify where we're moving and help you generate some ideas on how you too can start utilizing some of the capabilities in the future. So I'll be looking at the 4th grade teacher, grassroots community garden organization, up to like a state agricultural operations center, or even a nonprofit project manager, and even the homeowner. So let's focus on that 4th grade teacher. And let's say we have a 4th grade teacher located here in Norfolk, Virginia, in the United States, who is working on a lesson plan to teach her students about the interrelationships in Earth and space systems. In Virginia, the public education community is held to the Virginia Standards of Learning, or SOLs. And so happens that our teacher is working on preparing her students to meet SOL Standard 4.6. And this standard focuses on students' understanding of how Earth systems are connected. Several of the concepts include the understanding of temperature and air pressure and fronts and clouds. And she's preparing this lesson plan to be presented via an internet browser on her class's smartboard so the students can interact with the lesson as well. And for those that might be unaware of what a smartboard is, it's a large interactive board that students can write on and click buttons, very similar to a very large tablet that you could use with your finger. It's just presented from a projector. So as a K through 12 teacher, she's approved to use the suite of Esri ArcGIS online mapping tools for free of charge through Esri's Connect Ed program, to include the creation of web maps and online web applications. So this provides the teacher an ArcGIS online user account with access to data layers, mapping capabilities, and the creation of out-of-the-box applications she can put together for her students. Now, if the teacher were to visit the Esri Connect Ed website, she would also discover a plethora of other resources, such as predefined instructional materials that cover U.S. history and even more relatable earth science geoinquiries and human geography and many other predefined instructional materials. So let's say the teacher has her ArcGIS Online Connect Ed account, and now she logs into ArcGIS Online. Once she logs in, she can go through and browse several bits of information to include Esri's Living Atlas of the World and data layers that users have submitted as well. And we're working closely with Esri to prepare our SSE ArcGIS Image Services, or Web Services, to be published within Esri's Living Atlas of the World. This will make layers like temperature at 2 meters, or relative humidity, or global horizontal radiation more discoverable to our diversifying user community. Now let's say the teacher has identified which layers she wants to use for her SOL 4.6 lesson and begins building and customizing her web map within the ArcGIS Online. So as she goes through ArcGIS Online, she finds the different data layers that she wants and then begins to say, okay, I want to create a new map with these. And with the new map, she's able to actually have a new plethora of tools that are available to her. So once she's in the web map builder, the teacher can see the layers that she added on the left-hand side and turn them on and off. She can adjust their transparency. She could customize maybe what shows up in a pop-up box when the students actually click on the smart board to want to see what the value is at that level. She can add additional data to the web map by just searching for layers through ArcGIS Online or across the internet as well. And once the web map is actually where the teacher wants it and has the layers that she wants to provide, she can then share this web map as an application within her account. Now, Esri provides a suite of custom-built web mapping applications that the teacher can choose from. And without any knowledge of how to program, launch a web server, configure security settings, or ingest an ArcGIS image service, she's able to create her own story map application or data viewing application that can be displayed through the internet browser on her smartboard. And what you'll see here is on the side, I'm actually using a story map to give this presentation to you as well, and embedding additional applications inside of my story map. So let's say the teacher has actually decided on what application she wants, the data layers from the web map, some of the data layers being the annual temperature from our SSE Data Image Services and the atmospheric science pressure. And she launches this application. So while launching the mapping application from her web map, the teacher was also guided through a customizing template builder, which allows her to copy and paste information into the About Us section of this application. And this is where she decided to place information about her SOL 4.6 standard. And then she has the option in the legend to actually see what layers are turned on. And then in the layer list, she can actually toggle her layers on and off that she had in that web map. She also opted for the application that has a magnifying glass that hides and reveals the data layers of her choice. So one of those being, in this case, was the mountain ranges. So with the magnifying glass, as the students actually scroll around, they can see the outlines of the magnifying glass. So what's really nice here is now the students can actually click on the map using the SSC data, get the atmospheric pressure at that location, and maybe see what it is in relation to the mountain range as they click over the mountain range and get different values to see how it affects the pressure is affected with altitude. The nice other ability the teacher has when using the story map is she can embed YouTube videos where it might further explain pressure and altitude. She can turn on additional layers like the annual temperature, or even pull in things like weather radar data if she wants to show students, what the data is at that location for the weather currently, and show that it's snow. So when they go home and watch the news, they can actually see that it's what those symbols mean on the television. Turn on USA Core-based statistical areas if they wanted to look actually where their city is and what their values are within these actual areas as well, or zoom back out globally and see what it looks like for the pressure across the globe and across several different mountain ranges. The idea here, though, is that we're trying to meet the teacher where she is in the classroom when doing her lesson. She's using the SSE Data Image Services without having to know how to program, as well as being able to mash it up with other data sets to create her lesson plan and trying to meet that diversified user experience. So let's now transition to look at our second use case, and this one being that grassroots organization, that's working to identify areas in their city where they could have community gardens. And let's say they partnered up with their local university to go and take soil samples at different places to test for lead or other heavy metals. And they had that information perhaps stored in a database or actually being served out. Well, the organization could put together a web mapping application like this with their free ArcGIS online account, just a public account. Now, of course, a public account has some other limitations to it, but they could still create a mapping application for their interested members and mash up some of the data. So in this case, they choose to look at the soil sample sites. They want to pull in the SSE annual relative humidity data so they could see what the annual average relative humidity data at 10 meters is all around their city. They also were really curious at looking at the July temperatures at 10 meters as well to see at the height of the season in July on average what these temperatures actually were, so they might know what they were planting in their community gardens or what kind of plants they want to put in their rain gardens that can withstand some of these heats. And that could just, is really basic at a very regional, very small citywide level. And let's just kind of bring it back a little bit further to maybe a regional or a state level. And let's say a state agricultural center is actually looking at this data, and they're curious how the July temperatures as 10 meters are, and they want to pull in information for the near real-time weather station data, or they want to overlay their USA soil survey so they can actually look at soil samples in the area, or they're looking at the USDA plant hardiness zones on what plants can be grown in what regions, all the while being able to pull in and out our SSE Data Services using the image services but not knowing it. And once again, the idea here, and this is just a quick sample, is to really try to let them mash up the data and make more informed decisions based on whatever problem they're looking at the time. And we just want to make sure that our data is being made available to them when they need to make these decisions. So the next use case kind of looks at the business sector, or more specifically, a nonprofit project manager that may be responsible for monitoring the growth or advocating for the growth of national leadership in energy and environment design, or LEED, L-E-E-D, certified sustainable buildings. Now, perhaps the application they have has a database of, the project manager has all their points of all their certified projects being served out with what other program that they're using. And they're looking in their legend, they can see what's bronze or gold certified or what's platinum with their LEED certified buildings. And say they're curious as to where their projects fall within cooling degree days. And so they pull an SSE Data Product image service into this application. They pull it in through, say, ArcGIS Online, and they're looking at the July 22-year average cooling degree days. Now, cooling degree days is kind of a unit of measure that a lot of folks use to help size air conditioning units that have to cool large buildings. And it's very important for like LEED certifications and green energy and sustainable buildings. So the idea again here is then they're able to actually look at their data alongside the SSE data and not having to look at several Excel spreadsheets and numbers and trying to look at them in relation to different numbers. They can actually visualize their data. And let's also say that their data was time enabled, that their locations were time enabled, and they wanted to see their certified LEED locations overlaid on top of the cooling degree days. So with that, their data being time enabled, they could actually enable the time mechanism within our GIS applications and watch their data grow over each period of time and pause it and scroll back and forth and then actually see where it falls within the cooling degree days image service that we're providing out. One of the other things that we're working on is we do have a lot of daily averaged data that we're working to put out in a daily time series so the user could do the same scenario but within our global parameters from a daily perspective. It's a limited set of parameters, but they could see temperature by each day going through a times ladder along with maybe their projects. So that leads me to our last use case, which is the homeowner. And now the homeowner may be interested in installing solar panels on their home and may visit an organization's mapping application that's consuming our insolation incident on a horizontal surface parameter, which is an ArcGIS image service. Or it's on the back end, the service from a REST or JSON is being consumed into an application, just the data itself, not even visually. But here we'll just say that they had an application that they're consuming the image service in that they created. Well, this parameter itself is being one of the main inputs to kind of get a rough estimate of how to size solar panels. As you can kind of see in this equation, the average insolation is an input to this rough equation. So the homeowner can actually look and say at their electric bill and see their kilowatt hours totaling for this billable period from January 22nd to February 22nd was around 1,300 kilowatt hours. Divide that by the current billing days, 31 days, and when they do that, they can find that they do use about approximately 44.5 kilowatt hours per day. And they could do the same for their usage history over the entire year to actually kind of get their annual usage in kilowatt hours per meter squared. So at that point, that 44.5 kilowatt hours per day is now an input into that equation. And then what the user can do, which is their average daily electric usage, and then that's divided by the average insolation. So what the user is able to do is gather their average insolation from our image service, so 4.24 kilowatt hours meter square per day, or say the user needs to know their address, they could use the Esri geocoder and find their address and actually zoom in on the map to get their location information. They also have the ability to, besides using the geocoder, they can also using Finding My Location, which uses the computer's IP address or the mobile phone's GPS technology if they so allow it to be turned on. And then they can turn additional layers on and off. If they don't want to just see annual, maybe they want to see the January average because that's the area that they're doing January to February, and they're curious what their average insolation incident is for January or February. They can turn each of those values on and then just click on the map and get both of the values based on what they're actually looking at. And so that's kind of where the homeowner is in installing those solar panels on a very basic, trying to meet the user, the homeowner, on the couch, on their smartphone, because these applications are already responsive. And so the application itself will readjust to a smartphone size or readjust to a tablet or readjust to that smart board. So with that, I wanted to kind of bring you in to the SSE Web Mapping application. So let's say none of those applications are out there yet. The teachers aren't creating the applications yet. The image services are out there, but none of those capabilities exist yet on the internet. People haven't started creating them. Well, what we wanted to do is through the SSE website, create a web mapping application that kind of helped provide our data back to the user in a more visual and analytical means than just the ASCII and HTML tables. So from the SSE website, the users will be able to access this surface meteorology and solar energy mapping application. And they'll be presented with a splash screen that kind of provides them each of what the widgets are, the tools, and the definitions about what they are. They also have the same basic kind of base tools. They can find their location based off their IP address or their GPS location on their mobile phone. They can use the little house symbol to kind of go back out to the default extent, which just pulls the user back out globally. They can zoom in, they can zoom out. They could change the base map gallery. Say they were curious in a National Geographic base map, or they want to see something more with terrain, or they're interested just in the imagery. They can adjust the base map of what they're doing. They have some basic capabilities to draw and mark up on the map application if they want to print it off. They can make some basic markups. They can do some measurements in both linear and area-wide measurements as they zoom in around the map. They also have the ability to bookmark, and they can create bookmarks. So if they zoom into a particular area and they want to bookmark that level and then zoom back out to another area, they can make those bookmarks so they can go back and reference it later. So that's kind of the base options. They're also provided their decimal degree locations down in the lower left corner. So anywhere they scroll around the map, they can kind of get the latitude and longitude degrees. So what we wanted to do over here is in our layer list, actually provide the user a visual example of what the data looks like. So they could select the parameter that they're normally used to going to on the SSC website, and say they select a month and they're looking at January. They can actually click on January anywhere on the month, just like the other ones, the other applications, and get the values anywhere around the globe. They're getting those values of that data set. The nice part is they're actually getting a visual representation of what the data looks like. It's not ASCII, it's not HTML. They can also adjust the opacity, the transparency of the layer, so if they've got something underneath that they want to see. The other nice part is on the SSE website, I mentioned the global data sets download, where a user could actually download the data and they could receive it in the ASCII format. So that's used by a lot of users, and we wanted to make sure that that capability also existed within this application. So we created a global data sets download, and the user can select the ASCII format and still choose the parameter of their choice, just like they do on the website. And when they hit download data, they get the same ASCII or text file that they would see on that other screen. However, the other option we wanted to put in was this GeoTIFF. Now, a GeoTIFF, or a TIFF in general, is pretty much just an image. A TIFF can be used in PowerPoint, it can be used in a photo editing software, but what makes it a GeoTIFF is that it has some geospatially referenced information within the metadata of this TIFF. So each pixel within that image actually is referenced to some point on the Earth. And what's really nice, especially for geospatial users or that community that wants to pull it into a map and actually make it useful where they click on the image, it'll orient itself based on that coordinate system. So now they can download the data in the Geotiff format, where they can choose the same parameter that they're interested in, and then also choose which month they want to see. So the idea is they could download the same green and yellow-red global horizontal radiation image that I have on the screen, which is just January, global horizontal radiation. They could download that as a Geotiff file and bring it into their applications, or also just bring it into PowerPoint or what they need to do. The one other widget that we've currently put in right now is the data tables. So on the other SSE website, the user would have to know their latitude and their longitude. And they'd have to know that before they could actually get to the parameters list. So what we wanted to do here was apply the ability for the user to just click a point on the map, and it automatically populate their latitude and longitude. And then they could select one or several of the parameters from the select parameters list. And then once they do that and hit submit, the traditional user would then be presented with an additional tab that opens up that gives them the table that they're kind of used to. Gives them their latitude, their longitude, parameters, units, and then those 22-year average values. This table can be just highlighted and copied and pasted back into Excel, back into applications, just like they're used to. The nice benefit is that they're actually able to just put a point on the map, use their IP, get their GPS location. If they're out in the field, hey, I'm in the field, I know my tablet is using this GPS location. I make the point on the map where I'm actually standing, and now I have my lat long, and I want my parameters, and then they can get the table and get their values. The other option that we have is this regional data set subset. So with the regional data subset, is several users kind of need a larger area, a region that they're interested in. And many users may not know the bottom left-hand corner and the upper right-hand corner of their bounding box. And so what we wanted to do is provide them another drawing tool so they could highlight the area that they were interested in. And they knew they were getting maybe over an entire city or their neighborhood or a state. And then what that would do is automatically provide them the bottom left and the upper right-hand corner coordinates for them, and then they can visually see that they're getting the data layer and the area that they're actually interested in. And then they can actually select the parameters, again, one parameter or several parameters, and hit submit and be presented with that table that they're used to, where they can download it, put it in Excel, or whatever they need to do, what they've been doing in the past. Lastly, we have an information widget where the user can go through. It's the same information that was on the splash screen. It just kind of provides them a reference if they're trying to remember what each of the symbols stand for. And we also have an application support widget where the users can submit comments and feedback in the form currently while they're in the application. They may see something that says, hey, this isn't working, or I'd really like to see this, or in the future, could you develop a widget that did this? They can provide that feedback within the application while they're there, and it's on their mind. We also provide the release notes and then any kind of future app developments that we're working on currently, so they can kind of get an idea of where we're going. So speaking of new app developments, what I wanted to point out is that the new apps that we're working on right now are allowing the user to actually view each of our parameters in that daily time series, as well as play through each day based on a temporal range of their choice and download the data for that day as they need. And so this is a new widget we're working on inside the application. They can actually step through each of the days and each of the layers and then download or retrieve data for a particular day within that period. The other development we're working on widget currently is the interannual variability tool. And this capability allows the user to retrieve those monthly average values for each year within the time span of their choice, and then they can get it in that table just like they're used to, but allows them to actually choose the year, choose the parameter, visualize what the parameters look like, and then get the table. So in the SSC Web Mapping application demonstration, I mentioned that Geotiff. So real quickly, let's just say we had a geospatial user or someone who had access to like a ArcGIS software. So the Geotiff data can be downloaded from that web mapping application and then can be added to ArcGIS. and any other open source GIS software package. And then it can subsequently be used in their geoprocessing tools for further analysis and visualization. So for example, a user here actually downloaded the Geotest, selected the color ramps, did some clipping, and provided some additional geoprocessing tools right here within the ArcMap software. Also, for the geospatial user, the ArcGIS Image Services can actually be directly added to this software by connecting to our ArcGIS server and pulling in our services directly and making use of the plethora of image geoprocessing tools inside of ArcMap. And so for those attending this webinar that are NASA employees or NASA contractors, there is a NASA Enterprise License Agreement that provides this software free of charge to the NASA user, and so you guys can actually use the image services inside of ArcMap as well. Now I also wanted to kind of talk to, from the diversifying user group from the 4th grade teacher to the geospatial users. Now I want to also talk to the developers that might be joining. And for those that are attending that are developers, I did want to point out that you can interact with our SSE ArcGIS Image Services using the JavaScript through the ArcGIS API for JavaScript, and the image services are RESTful services. It can be accessed using standard REST protocols. And so the ArcGIS API for JavaScript is designed to maximize your productivity for building engaging and beautiful web mapping applications. And this JavaScript API provides lots of JavaScript methods and functions that the user can directly pull in our image services and mess with our image services when they're creating their own web mapping applications. There's an entire library of sample code out there that the users can actually see the code, the JavaScript, pull in our image services, and also play with it within a sandbox. So with that, just wanted to let you know, looking into the future, we are working towards a 30-plus year climatology for monthly and annual SSE data products that would be at a half-by-half degree resolution and will replace the current 22-year product that we have. However, at this stage in the project, we wanted to work to make sure that we upgraded the capabilities to take advantage of those geospatial delivery tools and serve out that 22-year climatologies. So with that, I just wanted to thank you for listening in today, and if you do have any questions on SSE or the GIS capabilities, please do not hesitate to contact us. And with that, I will now go ahead and just turn it back over to Jennifer.
Okay, thank you, Jason. Thanks, everybody. What we'll do next is we are going to move to a final set of polling questions. I'll give those questions just a couple of minutes or so, and then we'll move from there directly to the Q&A period. And we do have one of the, or DPI for the SSC project, Dr. Paul Stackhouse, going to be dialing in for the Q&A period, so do be sure to stay on the line and or in the meeting room. So we'll go with that in just another couple minutes, all right? Thanks so much. Okay, everybody, we're going to give these questions just another 30 seconds or so, and then we'll jump directly to the Q&A period. Thank you. Okay, at this point, we are going to move to the Q&A period. And I've made note of some of the questions that were asked earlier. So, Paul, are you also online?
Hello, yes. Yes.
Okay, fantastic. So I'm going to start with our, go through all of the questions. I know that you'd answered a couple by text, but I want all of our users to benefit from the answer here. So moving back up to one of our first questions, if everyone would bear with me here. So the first question was, are you planning to increase the resolution of the data? And that really has been answered here, the spatial resolution of the data. Lars, are you satisfied with the answer of the, the half degree by half degree data? And if Paul or Jason, if you'd like to add to that, that would be fine.
Yeah, we're just in the process. We wanted to finalize these GIS-based web tools and applications first, and then provide. But we've already in the background, we're testing the half-degree data. We're evaluating first. One of the things we really do spend a lot of time doing is validation and assessment before we release the data. And that way, we provide all the documentation on that so that a user can get an idea of the quality of the data. So that's what we're in the process of doing.
Okay, wonderful. Thank you very much, Paul. And the next question is, I currently import the SSE data via an Excel web query. Will this functionality remain?
Yes. So currently, if you're talking about using like through a URL, the CGI call, making the query, that function is remaining. Because we have a lot of users that still access the data directly using that method. The image service is going to just be an added benefit, so you can take advantage, one, for a lot of the JavaScript API tools if you want to build out more robust applications. There's a lot of built-in functionality that you can use the image service, along with it just being a REST and retrieving it back as JSON. But to answer, yes, that URL CGI request option still remains.
Okay, thanks, Jason. Jason, you may need to move a little closer to your microphone. Your audio is a little bit less pronounced than it was a few minutes ago. All right, so the next question is there an accessible database of the organizations and companies who are using SSE data?
I don't think that exists. So I guess the answer is no. We don't have specific user information to that level. We do have general information. For instance, that information that was provided on the various countries is mainly because of the URL identification for the source of those queries to the data set. But we don't have we have information regarding some partners, but we don't have information regarding the entire user base. There's privacy rules and restrictions that we do honor.
Yes. Thank you, Paul. Okay, the next question here. How much can we consider, I think one of the questions before this was with respect to the temporal range for the data products. Currently.
Yeah, the current temporal range spans from the 1983 time period through the 2005 time period, but this is going to be upgraded from the solar data be from 1983 forward to essentially present. We'll probably pick a 30-year period that starting in 1984. And then for the meteorological data, we might be able to extend that a little further backward to about 1980, because that's where the reanalysis data products we use from NASA Goddard originate, and they also run through present. So we'll be, I think what we're going to be doing is we're going to replace the climatological aspects on the site with a 30-year data set that starts in the 1984 or 1985 timeframe, and then we will also provide access to what we call a near real-time data stream, which is about a week behind real-time, and that allows for provision of data products, daily average data products at this time, up to within a week of the present day.
Okay, wonderful. Thank you for that answer. The next question is, how much can we consider the variability or uncertainty for the insolation data that are made available in the EOS Web data sets?
That answer, overall, we compare to surface measurements on a globally distributed network. The bias is fairly reasonable within a percent. The RMS is higher on a monthly average. It's about to the 5% level. It daily and 3 hourly data sets that are available in other places, but the daily data are up to the 10 to 15%. And of course, the answer always does depend a bit on where the specific location is that you're interested. So if you're near topographically complex areas or areas of complex and variable aerosols and those sorts of particulate matter, that can cause the larger uncertainties in those regions.
Okay, wonderful. Thank you. The next question is, what is the simplest way to convert HDF to NetCDF format?
Well, there's several, I know there's a couple tools out there that you can use to convert HDF to NetCDF. I don't know about the simplest way. All of our data currently right now is not provided in HDF. We actually store our data on the back end, and that's served out. It's actually stored in a NetCDF format. So if you are looking at, if you're interested in some of these data sets in a NetCDF format, you can just reach out to us currently. That's going to be another option in the future for the download, is that the users can get it in NetCDF format. But actually converting from HDF to NetCDF, there's just several different tools out there. I couldn't name just one, and I don't know.
Yes.
So, yeah.
And one additional resource for this user, I can email you offline. There's the HDF Group. There's a website that actually provides a number of examples of tools organized by, your platform that would actually convert HDF into a variety of different output formats. So I can email that URL. Okay, hopefully that's helpful. That's moving on to the next question here. The next question is, where do each of the types of users you showed go to get information on the quality of the data they are looking at? For example, uncertainty, accuracy, etc.
We have methodology documentation. I don't think Jason pointed to that on the, but it is there, and it's also on the traditional forms of the website, which we'll be retaining. So there will be links right on the website that has a complete methodology document. We not only provide information regarding the origin of the data sets, but also the sorts of validation that we've performed. And then if we derive parameters, we give you all the mathematical equations that you need to verify those. And if you rather have your own equations, then you can work with that.
Okay, thanks very much for that response. I just wanted to point out to everybody as we are, going through the Q&A, that if you look in the lower right-hand corner of your screen, for those of you interested interested in downloading the presentation, it's also been created in a PowerPoint. So if you select either one of those two files at the bottom to highlight those, left click, you should be prompted with an option to download that file. And there will be an opportunity when the webinar has ended to stay in the virtual space and download the files if you would like. Okay? And now moving on to the next question. Climate, well, it's more of a question and comment. Climate has changed a lot during the last 10 years. Why is there no data available after 2005?
Well, there is actually data available after 2005 on our power.larc.nasa.gov website. We just don't have it available in the GIS apps that we wanted to demonstrate today. That transition is ongoing, and in the next couple of months, after we publicly release this version of the website with the web capability, we'll be migrating the new data sets over. So then the data will become available.
Okay, thank you. And I think that also answers the next question, which was with respect to the time frame as to when the data after 2005 may become available. So I believe that question has been answered as well. What is the difference between insulation for solar cooking and insulation on a horizontal surface? Pardon me.
I'd have to double check, but I think they're the same. There is the ability to tilt some of those solar cookers to a particular angle. We also have the capability on the SSC website to look at the irradiance for a given tilt angle. So I think the horizontal surface is, of course, the surface like a tabletop. It's horizontal to the surface of the Earth, and a tilt, of course, is tilted usually toward the sun relative to that horizontal.
Okay, thank you. The next question is, what would you advise for students who would like to do research on wind and solar potential in power generation? Thank you.
Well, I don't know, Jason, if you want to add in, but certainly you could look first at the, it depends on what kind of technology you're looking for the sorts of data parameters that you would be interested in. The solar parameters that are provided, if you are interested, for instance, in photovoltaic, say a photovoltaic farm of some sort, then you could use our estimates of the what we call the global horizontal irradiance, or the solar irradiance at the surface. And then there's information on tilting those photovoltaic panels. Those photovoltaic panels really are sensitive to the total irradiance, so that would be the direct. So if you can see the sun, that's direct radiation. Diffuse radiation or sky radiation is all the energy that comes from a direction not in the direction from the sun. And so the photovoltaic is sensitive to that energy. If you are looking at solar concentrated power, where you're using some sort of a mirrored system, then you are very concerned about the direct energy, because the mirrors focus that direct energy to heat some sort of material that is circulated and used to store the heat energy. So it really depends on the sort of technologies you're interested. In terms of winds, the wind information is there is really a first cut guide. Wind is far more sensitive to a specific topographic area that you're interested in, and it can be very sensitive if you're to even vegetation and other things. So wind requires a much higher resolution sort of modeling to do a comprehensive study, but these sorts of large-scale data provide a sense of where you might find larger wind speeds on average and would represent a first cut. And really all this data represents a first cut in terms of looking for resources. You would want to use some sort of decision support tool to help assess different technologies in different areas. For instance, Jason mentioned the RET Screen tool that we have partnered with, but we've also partnered with a tool called Homeowner. So those sorts of tools can be used to they use our information to do a first cut feasibility study. And then from there you can have to do more detailed studies for specific projects.
So this is really excellent feedback, and I think what might be useful too is that I can put both Jason and Dr. Stackhouse in contact with this participant offline so that you might have an opportunity to further define your specific research, and perhaps then the response could be guided specifically to whatever it is, whatever questions you're trying to answer. So I will do that when the webinar is complete. Thank you. So the next question is, I'm trying to present TOT-DET data from series on a WGS 84 model. Can this be accomplished with the current GIS services?
I'm not sure I understood that one. You probably have to submit that one too.
No problem. So Ray, I will follow this, forward this question along, and you can have this addressed offline. All right, so the next question is, what is the accuracy of this data? This data also include GHI, DHI, and DNI?
Yes, that is correct, and the accuracy information is available via a document that we've prepared. You can look at the current data. You can look at the SSE website and find that accuracy tables or the methodology documents, or also at the power.larc.nasa.gov general site there, and that has links to the methodology documentation.
Okay, thank you. And I think perhaps the next question might need to be part of from the same participant, and then add MODIS and MISR layers to the raw series TOT DET data. I'm not sure what that stands for, if that's, the series data is different than the SSE data that we're speaking to today, but certainly, this question can be addressed offline unless either Jason or Dr. Stackhouse have an answer to this.
Well, I can't really answer specifically, but series data does have many of the same products, and also at one degree, and we, of course, I'm part of series team, so we work with them, and we are looking at migrating part of these products to these data products as well. But you can the user can go right to the series website and look for the tab on the series science page. Just Google NASA series. It should take you there. Series is spelled C-E-R-E-S. And then you'll see a data access tab. If you click that tab, you'll see the list of the data products that are available, and there's now a subsetter and a data viewer there. So you can start to get a sense for those products, and you can order those products there. And I believe you can order them in that CDF as well. So, and we are actually working with the series team, and we hope to bring some of these GIS tools and allow users to directly display the series data sets through the GIS web services as well. So that's coming.
Real quickly, Jennifer, I think in regards to the first part of that attendee's question, if they're asking if we can actually bring in our ArcGIS services and then reproject them into a WGS 84 coordinate system, if that's what they're asking, the answer is yes. The GIS services are They're in a particular projection that's good for sharing data over the web, but the user can reproject them very easily into a WGS84 coordinate system model so it aligns up properly with their other data.
Okay, thank you, Jason. All right, moving on to the next question, and I should note that we have about 5 more minutes for the question and answer period. So if we don't get to all of the questions before that time has, completed, these questions will be answered either in the Q&A text box or via email, okay? All right, so the next question is, how quickly will the previous year's data be available?
Does the user mean like from 2015?
Gina, if you're still on the line, could you elaborate, please, in the Q&A pod?
Well, the quick answer is the user can go to power.loc.nasa.gov and look at the near real-time links to near real-time data, and they can get some data for a particular location that spans all the way back from 83 to near present. We are a bit delayed at the moment. We'd like to be within a week, but perhaps some users on the phone know that Terra Modus had some difficulty, so that's disrupted our product stream at this moment. But we're working to try to resume that stream.
Okay, wonderful. Thank you. The next question is, if a homeowner wants to find out what the percentage error is on the estimate of solar panel area that was commuted? Where does he go? Computed, excuse me.
Where did he go? That's a good question.
I have to
answer that one offline. I don't know.
Okay. Well, we can address this offline as well. The next question is, which satellites are generally used to obtain the irradiation data, and how do their parameters vary depending on the location of the orbits?
Well, the products that are generally used are from the Earth's polar orbiting satellites, from the AVHRR imagers, if you're familiar with that. So we have 2 polar orbiters, morning and afternoon, plus all the world's geosynchronous. So all those are cross-calibrated and algorithms are run, plus information about other atmospheric constituents for the entire time record. The series data sets use the Terra and Aqua platforms plus the geosynchronous. So I guess that's a short answer to that question. There's a number of satellite systems involved.
Okay, thank you. The next question is, if the data is in half-degree resolution and I change it to 0.2-degree resolution using software like CDO, so can we do it this way to convert grid resolution? If yes, why? If not, why?
It would depend on the parameter. Usually surface elevation does have a lot to do with the variability of these parameters. So a straight interpolation might cause problems depending on the topographical area. Clearly over the ocean you can clearly do that, but I don't think the user is primarily interested over the ocean. But so it really has to do with the sort of terrain that the user is interested in converting these parameters to. And the solar is similar. If it's a high elevation, there is less scatters in the atmosphere to scatter light. So you tend to get higher irradiance. So there is some correlation with elevation and the increase of solar radiance. So that would have to be taken into account. Temperatures and pressures, of course, pressure is very sensitive to the elevation. So really the proper answer is it really depends on the parameter and what the user is interested in. Another example where this won't work would be the precipitation, where you can tend to get elevation enhanced precipitation events on the side of the mountains where the wind is blowing. It's called upslope, and drying on downslope. So those things can definitely affect both cloud distributions, which affects the solar as well. So that would tend to cause a lot of complexity and problems in doing just a straight interpolation.
Okay, I'm going to take only this one last question because we're out of time and we've used the extended Q&A period. What free options are available for exploring the data in GIS format? Anything via NASA or .gov sites?
So from an application standpoint, Esri does provide an ArcGIS Explorer, I think is what it's called, similar to something like what you would see with Google Earth or something. And that's a free download where you can explore data sets. And you should be able to have the capability to bring in some image services and other GIS data into that software, ArcGIS Explorer. I don't think they've changed the name since then.
Okay. Thank you, Jason. So what we're going to do now is that we're going to log off from the telecon, but if our Q&A panelists could stay in the virtual meeting space for a couple of minutes, we should be able to, answer this final question here regarding the MERA 2D reanalysis data. I'd like to thank everybody for joining us today. Our next regularly scheduled webinar will be held in April, on the 27th of April, and we'll focus on cryospheric data products and data discovery tools from our National Snow and Ice Data Center. So stay tuned. We do have a listserv where you can sign up to receive announcements for upcoming webinars and data training. If you go to the tinyurl.com, Earthdata webinar, and again, the presentations are available for download below. So I will leave the virtual meeting space open for 10 more minutes. If you're interested in downloading the files, again, you would select the file and you'll be prompted to download that specific file. So thanks very much, everybody, for joining us today. At this point, we will log off from the telecon, but the room will stay open until 3:27. All right, thanks, everybody. Bye-bye now.